Hi students, welcome to my channel. Today we are going to discuss previous year NEET questions from optics chapter. Our first question is, a lens of large focal length and large aperture is best suited as an objective of an astronomical telescope. The reason is, he's asking the reason. So this is our astronomical telescope. This will call it as objective, and this we will call it as eyepiece. Now what he is saying? He is saying that the aperture of the objective is large, and he is asking us the reason. We know that this astronomical telescope is used to see the distant objects like moon and stars. Since moon and stars are at a large distance, the amount of light entering into the objective will be less. Now if the aperture of the objective is more, then what happens? More amount of light will be collected by the objective. So that is our second option, that is larger area of the objective ensures better light gathering power. So if the aperture area is more, then more amount of rays will pass, that is this telescope will collect more amount of light. Now, and we know that the intensity of the image is proportional to the size of aperture whole square. Now what happens? If the size of the aperture is more, then the intensity of the image will be more, because of which the visibility of the image increases, the quality of the image increases, and even the resolution power of the image will also increase. So the answer for this question is all the above. Now let us move to our next question. A convex lens A of focal length 20 centimeters and a concave lens B of focal length 5 centimeters are kept along the same axis with a distance d between them. If a parallel beam of light falling on A leaves B as a parallel beam, then the distance between them in centimeters will be. Now let us see what he gave. He told that this is a convex lens of focal length f is equal to 20 centimeters. And this is a concave lens of focal length f is equal to 5 centimeters. And he told that he placed this convex lens and concave lens on the same axis. At a distance d, that is the distance between these two is d. Now what he is saying? He is saying that a parallel beam of light is falling on the convex lens. Now the condition is, for the emergent ray to be parallel, what is the distance? So you have to calculate the distance between two lenses. Now this is a convex lens, and on this convex lens parallel rays are falling. We know that if parallel rays fall on the convex lens, what will happen? These rays will converge at the focus of the convex lens. We know that the focal length of convex lens is 20 centimeters. That means this will be the focus of convex lens, and this distance will be 20 centimeters. Now the condition is the emergent ray should be parallel. For this to happen, we have to place the concave lens at such a position where this focus of the convex lens will be the focus of concave lens. The reason is, we know that when the object is at focus, the image will be formed at infinity. That is, the emergent ray will be parallel. So that means this point should be the focus of concave lens. That means indirectly we can take that this distance as 5 centimeters. Now this entire distance is 20 centimeters, out of which this is 5 centimeters. Then this distance, which is nothing but the distance between two lenses, will be 20 minus 5. D will be 20 minus 5, that is equal to 15 centimeters. So the distance between two lenses should be 15 centimeters. On a whole, if you see what is happening, a parallel ray is falling on convex lens. Because of its converging nature, it converges. Now this converged beam is falling on concave lens. Because of its diverging nature, what happens? This diverges the converging beam such that the emergent ray is parallel. Now let us move to our next question. Find the value of the angle of emergence from the prism. Refractive index of glass is √3. Okay, so what is he gave? What did he give? He told that this is a prism which is made up of glass and refractive index of glass mu g is √3. And he is asking us to calculate the angle of emergence. E is equal to how much? That is this angle. Okay. Now, if you see, this is the incident ray which fell on the prism in normal direction. That is, our angle of incidence will be 0. Okay. Since angle of incidence is 0, then angle of refraction or angle of reflection both will be 0. Okay. Because of which what happens? Without getting any deviation, it travels like this. Okay, and it falls at the point U of the prism. Okay, at U what is happening? It is traveling from, so it falls with some angle of incidence I with respect to this normal. Okay, now at U what is happening? It is traveling from denser to rarer medium, because of which it bends away from the normal. So what happens? Instead of traveling like this in a straight path, it bends away from the normal with some angle, that is E. That's what we are supposed to calculate. Okay, now this is right angle prism where he gave this angle as 60 degrees. Okay, and this angle is 90 degrees. Then this will be 30 degrees. Okay, now consider the triangle AUV. Okay, where since this is normal incidence, so this angle will be 90 degrees. That is angle V will be 90 degrees. And this is 30 degrees, then this angle will be 60 degrees. Okay, now since this line is normal, so this angle will be 30 degrees. That is, your angle of incidence I is equal to 30 degrees. And you are supposed to calculate the angle of emergence on the plane AB. Okay, on the plane AB. Okay, now what we will do? At U, we will apply Snell's law. That is, so ray is traveling from glass to air. So what happens? Refractive index of glass into sine of angle of incidence in glass, sine I, is equal to refractive index of air into sine of angle of emergence. Okay, refractive index of glass is √3 into sine of angle of incidence, that is sine 30 degrees, is equal to refractive index of air 1 into sine of angle of emergence. Okay, sine 30 is 1 by 2. Then what will I get? That implies sine E is equal to √3 by 2. That implies E is equal to 60 degrees. Okay, so that means this emergent ray will emerge with an angle of 60 degrees with the normal. Now let us move to our next question. A point object is placed at a distance of 60 centimeters from a convex lens of focal length 30 centimeters. If a plane mirror were put perpendicular to the principal axis of the lens and at a distance of 40 centimeters from it, the final image would be formed at a distance of. Okay, so what did he give? He told that this is a convex lens whose for this convex lens he placed an object. Okay, he placed an object at a distance of 60 centimeters from the pole of convex lens, and he told that the focus of this convex lens is at a distance of 30 centimeters. Okay, then what did he say? And on the principal axis, perpendicular to the principal axis, he placed a plane mirror. Okay, a plane mirror which is at a distance of 40 centimeters from the convex lens. Okay, now he is asking us to calculate the position of image or the position where image is formed. Okay, now this is focus which is at a distance of 30 centimeters and he placed the object at 60 centimeters. Okay, he placed the object at 60 centimeters. That means what does it mean? It means that object is at 2f. Okay, twice the focal length. Okay, now let us see the other end. So the other side, this will be the focus. since the focal length of convex lens is 30 centimeters, so this distance will be 30, and this is twice the focus, then this entire distance will be 60 centimeters. Okay. Now what did he give? He told that he placed the object at 2f. So in the case of convex lens, what happens? If the object is at 2f, then image will be formed at 2f, that is at a distance of 60 centimeters from the convex lens. Now because of which what happens? The ray coming from the object will travel like this, gets converged and travel towards the mirror like this. Now since we placed the mirror at a distance of 40 centimeters from the convex lens, what happens? This diverged ray will hit the mirror and get reflected back. Okay. Now, so what happens? This image formed by the convex lens should be in reality it should be real image, but because of this mirror, what will you get? You'll get a virtual image I dash. Okay. And since this entire distance is 60 centimeters and this is 40 centimeters, then this distance will be 20 centimeters. That means the image, that is the virtual image formed by the convex lens, is at a distance of 20 centimeters from the plane mirror. Okay. Now this virtual image for the plane mirror will act as virtual object for the plane mirror. Okay. Now, and we know that in the case of mirror, the object distance will be equal to image distance. That means the image formed by the mirror, that is the image formed by the mirror because of this virtual object will be real and it will be formed at a distance of 20 centimeters from the mirror. Okay. Now this entire distance is 60 centimeters. Okay. And out of this distance is this entire distance is 40 centimeters. Okay. Out of which this distance will be 20 centimeters. That means this distance, that is this will be 20. That is the image formed by the plane mirror will be at a distance of 20 centimeters from the convex lens. Okay. Now if you observe the convex lens, so in next case, that is in later case, the object is at a distance of 20 centimeters and the object is between pole and focus. Okay. And we know that in the case of convex lens, if the object is between pole and focus, the image will be formed on the same side of the object and the image will be virtual. Okay, the image will be virtual. So we came to conclusion that the final image is virtual. That means, so first option will be wrong. Fourth option will be wrong. So the chances are second option where it gave you virtual image, and third option where it gave you virtual image. Okay. Now the position is, you have to find the position of the image. That is whether the final image is formed at 30 centimeters or 20 centimeters. Okay. Now we know that, now we came to conclusion that the image after reflection from the mirror is formed at 20 centimeters from the convex lens, which is nothing but the object for the convex lens. Okay. So object is here now, and now we'll take this direction as positive. That means the object distance will be u is equal to minus 20 centimeters. And since this is convex lens, its focal length f will be equal to plus 30 centimeters. Now you have to find the position of v, which is nothing but the position of final image. Okay. For that I'll use 1 by f is equal to 1 by v minus 1 by u. Okay. 1 by f is, that implies, let me write here. 1 by f is 1 by 30 is equal to 1 by v minus 1 by u minus 20, that is minus 20. Okay, that is, that if this goes this side, what will I get? Plus of minus, that implies 1 by v is equal to 1 by 30 minus 1 by 20. If I solve, I'll get v is equal to 60 centimeters. That implies the final image is formed at a distance of minus 60 centimeters from the convex lens. Okay, minus means opposite to our positive direction. That means from here the image is formed at a distance of 60 centimeters from the convex lens, which is nothing but our 2f point. That is, the final image I double dash is again formed at 2f. Okay, so now we know that this entire distance is 40 centimeters, out of which, and this entire distance is 60 centimeters. Okay, then this distance will be 20 centimeters. That is, the final image is formed at a distance of 20 centimeters from the plane mirror. Okay, now let us move to our next question. If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Okay, do like and subscribe, because your single like and comment will encourage me for making better videos. Thank you.